My name is Mohit Sewak, and I'm from Microsoft. And the co-author of the paper are Dr. Sanjay Sahai and Himmat Rathod. They are from Bitslan, Goa. The major problem that we see in the case of deep learning for security is that deep learning requires a lot of label data to converge, which is not present in security. For example, data around malware, ransomware, these are very rare attacks and high impact attacks, but numerous samples around it. Because of which, sometimes it is seen that even very small classical machine learning models can provide much better results than deep learning models because these couldn't be converged with the amount of data that we have. This is not a problem only with security. This is a problem that is there with deep learning, but there are solutions available in other domains. For example, transfer learning is a very popular solution both for the area of vision and NLP across domains. There are other solutions also, like active learning, in which human SMEs could be used to give some feedbacks on labels, and those could be multiplied to other similar labels as well. Then there's supervision based models and systems like Snorkel, in which knowledge sources could be utilized, provide noisy labels, which could be used for deep learning. But none of these systems could be used for security for two basic reasons. Number one, unlike transfer learning, security doesn't offer a lot of unsupervised data. Transfer learning, for example, in case of language models like GPT-3, BERT, or Microsoft Turing, requires hundreds of gigabytes of web crawl data. But such data is not available in security. And for active learning based system, we require human SMEs that can understand the data and use human cognition to provide labels for it. But for security data, especially for malware or ransomware, you cannot just see a file and apply human cognition to label. Similarly, weak supervision is very specific to certain domains where knowledge repository systems could be used directly to provide labels, which is also not a condition that is available in security. And that is why we see a large gap, not just for security, but many other domains where these constraints doesn't work, and because of which deep learning is not very popular in these areas. So we provide multiple architectures of DRO, how it could be used. And one of the architectures that we present in a paper, DRO is used for an edge device, which is an Android mobile malware detection system. It tells which particular, it routes the incoming files either to the model, which is on the device, or to a dynamic analysis system, which is cloud-based. This offers two distinct advantages. Number one, the mobile resources are conserved and the battery is conserved because we only do some predictions on the mobile. The remains are taken to the cloud. And the second is Grow itself requires it's a deep learning model, and those deep learning features could be shared with the model as so anything that we do on Draw could be used. The second important factor over here is Draw could be used both for training and for inferencing. So you can have like a Draw based systems to provide better training with lesser amount of data, and Draw could also be used for inferencing, improving the inferencing and the prediction probability. So we have seen in the experiments that the DROID based system that we developed brought down false alarms by around 67% and increased the accuracy by 11% simultaneously. So these results are not just very significant from the quantitative perspective of unheard lift in both the accuracy and drop in false positives, but we trained Grow for develop a model for a particular type of class using features for which a model was not possible because the features were not very intuitive or informative in nature. And that brings the real capability of Grow-like system in training very highly potent classifiers. Now, how do we develop Grow? So at the heart of the Grow is deep clustering based systems. To be more specific, it is self-augmented training based deep clustering. We provide some mathematical enhancement to this such that it could be used for a purpose that we intend to. And all those enhancements are given in the paper. There are many advantages that Draw offers over other systems. Here we'll be comparing mostly with transfer learning because that is the de facto choice for deep learning. Other systems are not as much used in deep learning because the amount of data that they can produce is slightly limited to the constraints that they suffer from. So as compared to transfer learning, there are many advantages, specifically for the domains that we talk about. We highlight only here four key advantages. The first one is that unlike transfer learning, where the same model has to be pre-trained using the unsupervised data, and then you have to use this exact same model and continue it with further layers for the task-specific layers. This is a challenge because then most of the systems that we talk about or that are there already has some models that has learned important things that you do not want to lose. And many of these domains go through a very intensive cycle of validation to provide it for the safety guarantees and other factors. And that is why we would like to use the same model in many of these cases and yet enjoy the higher performance gains that could be brought down. So DRO model could be trained in isolation of the main classifier model, and it has the advantages of on-demand coupling, which means if required, it could be feedback could be connected, and otherwise it could be trained in isolation. The second important thing is that it is very efficient. So not only that it works in very less data amount, but it uses features which are very low dimension and very easy to extract. And that is the first attribute of efficiency. The second attribute of efficiency comes from the fact that it reduces the coverage to improve the performance gains, which means that not all the things not all the incoming file samples or records are channelized or routed towards the main classifier. Some are diverted towards cloud if they couldn't be classified by the main classifier. That also enhances the efficiency of the online systems. And the fourth important point is that it doesn't require any unsupervised data. So as we know that most of these transfer learning models require very large infrastructure to train or pre-train with very large amount of data. So because of all these constraints, pre-training these models is subject to only very heavy infrastructure facilities. And removing this, we can democratize the use of deep learning and training of deep learning systems to any of the machines that we have. With that, we'd like to say thank you and would like to take any questions if there are.